but I just could not work through to the proper answer.
No.
I couldn't either.
Ah.
It was rough.
Okay. What was the guy that we were trying to do? Have you got the details of him?
Number 8, use divergence theorem to calculate the surface integral f dot ds, calculate flux. F of x, y, z is equal to x squared y I plus x squared.
Oh,
Yep.
X squared y. Okay, next.
X squared y, x y squared,
Okay.
and 4xyz. All right.
Okay.
S is the surface of the tetrahedron bounded by the planes x equals 0, y equals 0, z equals 0, and x plus 5y plus z equals 5.
Okay. So we have, I'm trying to remember the letters. Not that it matters too much. I think this is called E. I want to try and be consistent. Is that E or R? Not that it matters. E will do. Okay, so we know we're going to do the divergence fella, right? And we're going to do a dV. I'm pretty sure looking at that it's going to be Cartesian. But, I might get proved wrong. Maybe it's going to end up being cylindrical. We'll see. I think the first thing I need to do is use this information here to generate the limits of integration on E, because maybe that's where you went wrong. So we'll start with that first. And the good news is that they all start at 0. So I already know 0 to something, 0 to something, 0 to something, right?
Mm-hmm.
When you got this equation here, what I would suggest, I'll put it here, what I suggest you do is to rearrange it typically as Z equals.
Yep, did that.
So that means that my Z's are going to go from 0 to 5, take away X, take away 5Y, right?
Mm-hmm.
Now I'm going to project that down onto the floor. So when you project something down onto the floor, what you're essentially saying is Z is 0. So what I now have is Y equals 5 minus X. And it might be helpful to draw that. It looks like this.
You're missing a 5 now.
Oh, what did I miss right? Oh, try that again. 0 equals 5, take away X, take away 5Y. So that makes 5Y equal. Can you hear my dog barking?
Yep.
I am going to have words with her in a minute, but hold on. We've got their little cages in here, so I forgot that she was in here. So are we happy about projecting this fella down onto the floor and getting this relationship? So if I look at this guy, it goes 1, goes down there. I believe this is 5. And there's our region that we're going to generate for the next part of it, right? Basically, the XY fellas. Now, can you remember doing this little trick of the rectangle?
Mm-hmm.
So what am I going to do? Well, I'm going to go from Y equals 0 to Y equals 1 take away 1/5 X. So that's where this limit of integration comes from. Now, there's only one guy left. Oh, so I don't lose track of things. dz, dy, and now we're going to finish with dx. And what's dx going to look like?
Should be 0 to 5.
0 to 5. Was that part okay, or did you maybe you went wrong there?
Well, I flipped the y and the x for slightly easier calculations, but
Yeah, nothing wrong with that. That'll work fine.
But yeah.
So far, so good. So that's not where the issue went. Well, we've got a function f, which I'm assuming, I don't see how this is going to cause trouble, but maybe it's just, whatever.
XYZ, by the way, on that last one. There you go.
Now, this is P, this is Q, this is R, right? So what you get? If you differentiate this with X, you get 2XY. If you differentiate this, you get 2xy.
Yeah.
And if you differentiate this, you get 4xy.
Mm-hmm.
Well,
Yep.
that's interesting. 8xy.
Yeah, that came out as it should have.
Okay, so still good, right?
Yeah.
Huh. I'm trying to think. It might just be messy fractions. I'm really not sure. You know, you can't split this.
Yeah.
You can't split it because these limits of integration will, I guess technically you could probably bring the x out, but it's not worth it with these two. So you have to kind of do it in the order that it's in. So if you try to do anything else, that might have been an issue. So it's going to go 0 to 5. We're going to do 0, at least in my case, 1 take away a fifth, but your version would be equally valid. Now, if you take 8xy and you integrate it with z, you basically just get 8xyz.
Uh-huh.
Evaluated at 0, and at 5 take away x, take away 5y. And then after that, we'll do a dy and a dx. Still don't see an issue, but it may be coming up any moment now. Well, putting in 0 is easy, so you only get the first one. So what is the first one? 8xy times this horrible mess, dy dx.
I think this is where everything started falling apart.
Okay, I think it's just because it's messy.
Right, that's all. But it was just impossible
Too much
Well,
to keep track of.
to get to
Oh,
the end of it.
Oh, okay. Well, look, I'll try. 40xy, take away 8x squared y, take away 40xy squared. How does that look?
Yep, that's
40.
the one.
Okay. dy dx. Okay. With respect to y, this guy becomes y squared, so you're going to get 20x y squared.
Uh-huh.
With respect to y, this is going to be y squared, so you're going to get minus 4x squared y squared. And this guy, yikes.
It's cubed.
Yeah.
Yeah, that's where everything started falling apart, because now you have to cube the function, and it's just
It was dx, by the way. And I've still got to put in 0 and 1 take away 1/5 x. Oh, God in Himmel.
see?
I'm not sure I'm going to do this to the end because I've got a feeling it's just going to be messy.
Oh, it's so messy.
It's 5 take away x over 5. I'm just going to rewrite this that way. I just try to avoid fractions. Can't really avoid it here.
Which is why I went dx first, then dy.
Right, that might be a little. There is a possibility here.
Hmm?
I'm just thinking. I'm not going to do it, but I'm wondering if that u sub might actually make it a little bit easier to deal with. Because these guys here, actually, even that would be better. I'm just thinking if I do that as a u sub, that'll become u squared, that'll become u squared, and that'll become u cubed. Oh, forget it. That's just going to take over and be just as ugly. Forget it.
But not quite as ugly.
I don't know
No,
if it's worth it. I'm doing ... which means have fun and do the best you can. I have no control over how ugly some of these answers are. Most of the time, they are really, really good at getting you. I've seen questions where the answer ends up being pi, and you're kind of in awe of the guy or girl who did that, and you're thinking, wow, that was clever how you managed to make that happen.
Apparently,
But
the answer
sometimes
to
this doesn't work.
Apparently, the answer to this one was 25/3.
Not arguing about it, call it good. I mean, I could fight my way through, but it's really just a massive polynomial, isn't it?
Yeah. It's just.
I don't even know if any of these terms play well together. They may not.
Yeah.
They may not
No, they
cancel
don't.
out or in.
Because once you get that cube in there, it throws everything out of whack.
Yeah. The fact that it's 25 thirds, I can almost guess why the third is there. That guy there's probably generating the third.
Hmm.
But why it's 25, which is a relatively nice
Because
number.
we're going 0 to 5 on the X's.
Yeah, but that would assume that there's an awful lot of this killing that off. I mean,
Well,
I guess
because
it's
when X's get squared or cubed, you still end up with a 25 on the end of it.
Mm-hmm. And these numbers here work well with 5 because they become zeros.
Mm-hmm.
So that might also be part of it. No, sorry. I think the reason you had trouble with it is because it's downright ugly. I don't think there's any shortcut or that you did anything wrong. I
It's
just think
just the worst.
It's just the worst. The thing, this is one of these ones where they change the numbers, isn't it?
Yep.
So I can see a really unfortunate situation where some of you didn't have any problems at all because the numbers played really well. You know, the polynomials come out really cleanly, and then others get stuck with these weird fractions all over the place. I don't think the software is clever enough to make sure that with any given number you get the same kind of quality question out of it. Well, at least we practiced going over the divergence theorem, so I guess we got something. Where will we want to go next?
Yeah, so that's probably one of those ones we would end up skipping over on a test.
Well, if you get to the point where you knew it was ugly, right?
Like,
and you're probably saying, no, I'm not going to spend 20 minutes doing that. Well, I'm going to look at it from the perspective that, as far as I'm concerned, that question is finished, isn't it? Apart from some really boring number crunching at the end.
Yep.
So, okay, you might lose a couple of points because you never finished it, but the 20 minutes that you gained by not doing it is worth it.
Better than spending half the time of the test on it.
Yeah, don't do that. Any question that's taking you too long, leave it. It's not worth the effort. Any particular thing? Right, here's true. Okay.
Actually, after this example, could we do a little change of variables?
Oh, good. Change of variable. I like those.
Yeah,
we'll finish with that one. Right. Let's do a change in variable. Have you, again, these are questions you don't make up, because if you make them up, they never come out good. Have you got one handy that I'll use instead? I can look at the textbook if you can't find one.
I could pull one up here. Let me see.
I know there was a change of variable on test 3 that was pretty rough.
Yeah. Yes.
Can't look at the test to check the number.
I think the kind of one that's coming to mind is something like x minus y equals 3, x minus y is 5, and xy is 7, and xy is 3. It kind of looked like that to it.
Oh,
Is that the
yeah.
one you're thinking of?
Well, those are relatively easy because it gives it to you right there.
Well, you know who the U and V is, but you still have work to do.
True, but...
Have you found one yet, Jacob? Or I'll just go to the textbook and find a section and pick some from there. As I say, I want one that I know is going to come out nice. If I just create one off the top of my head, it'll go south. It'll turn into something ugly we can't do.
I'm looking at the test right now. Let's see. Oh, I think I found it. So it's the double integral over the region R.
Right, hold on a second. I just closed off too many windows. Come back. Right, I'm going to go to the white screen, so I'll be writing that down in a few moments. We might already be in that white screen, on it. Right, here we go. Right, so it's a double integral.
And it is 7 times x minus 5y over 5x minus y.
Okay.
dA. And then R is the parallelogram enclosed by the lines x minus 5y equals 0, x minus 5y equals 2, 5 minus xy, sorry, 5x minus y equals 7, and 5x minus y equals 9.
Okay. So there's a generic, essentially it's a change in variable. And so what we're going to do is we're going to turn this fella here, and that's 7. I'm going to call u x take away 5y, and I'm going to call v 5x minus y. Are we all happy that that's kind of obvious what the change in variables are going to be? So this fella here, the x minus 5y, that's going to turn into 5u. And this fella in the bottom, that's just going to turn into a v. And then we're going to do that Jacobian guy, and then we're going to do a du dv guy, right?
Mm-hmm.
Now the limits of integration are u 0 to 2. So I'm going to put this in with a label on it so I don't get them back to front. And then v is 7 to 9. And then all we got to do is the Jacobian thing. So we're going to try and make sure I get them the right way around. And I think I got them the right way around for a change, didn't I? Because I always seem to want to go du by dx. Oh, by the way, I could have done du by dx. Can I switch places?
Yep.
And suppose the answer was 4, because I know it's going to be a number. Suppose the answer was 4. Wouldn't the answer be a quarter? Remember that little shortcut?
Mm-hmm.
If it's linear, you can switch it. Right. But since we have what it's here, I could certainly use that. Agreed?
Yep.
But if I'm going to use that, I just need to go up here, right? But then I'm going to say, but wait a minute, these guys here are the fellas I'm going to use, right? Okay, so here goes. So it's going to be, yeah, I got it right way around, so I don't need the numbering system now. Let's do the Jacobian. The fella that goes here, there's a fella that's going there, guy that goes here, guy that goes there. Okay, here it goes. If you do derivative of this, oh.
Yeah, you got to convert it if you're going that way.
Oh, no, I'm not.
There we go.
I'm going to do get the other one and turn it upside down, right? Because it's just less work. I could do it. Do you know what I would have to do is basically I'd have to solve these two. Do you know you solve it as a system of equations? Once I've done this, do you know what I'm going to do? I'm going to solve it anyway just to show you they're equivalent, because there might be some situations where these guys have x squareds or y squareds in it, in which case you're going to be in trouble, right? If you try and do the reverse, only works for linear. So anyway, in this case, that guy's 1, then it's -5. This guy is 5, and then it's -1. And going this way, it's -1. Take away is add. I believe I get 24, so what we're looking at, 1/24.
Yep.
So this guy here is almost negligible. In fact, couldn't I pull him out of the integral entirely and do 7 to 9? In fact, while I'm at it, why don't I pull the 7 out as well? In which case I've got a u and a dv, so if I'm going to do the 79, that's 1 over v. And then if I'm going to do the other one at 0 to 2 of just u, you all happy about just splitting it up?
Mm-hmm.
Since all the limits integrations are numbers, I can do that. I've just decided to pull the 7 and the 24 out here, and then just get that. So that's going to be a natural log of 9, take away natural log of 7. This is going to be a half u squared, which is a half of 4, which is 2. And then you're going to have a 7/24. So I guess the cancel Looks to me like it's 7/12 the log of 9/7.
Yep,
I'm
that's what I got.
confused because
Right.
I thought that the way you did it just now was you didn't take the inverse of that. It's whenever you solve for x and y.
Yeah,
Then
if you do it this way,
Mhm.
oh, you think I've got them back to front in my brain?
That's
No,
the way I
sure.
remember learning it the first time. It was
I hope I didn't do that. Oh.
No, it looks.
If I told you that or I gave you that impression, I am sorry.
okay. So
The idea
this
you
is like-
thought, keep the idea, but just switch places and you're fine,
yeah.
right? Now, just to kind of go through the process, let's do it the official way, right? The non-shortcut way. And so to do that, I need to return back to this question. And you sometimes can't avoid this, where you're given the U and V, which is fine, right? You still need to solve for X and Y if you're going to do this guy here, right?
Mhm.
Now, as long as this guy here is linear, and the reason why linear is good is because linear only generate numbers. You know, 5x or 10y, you're only going to get 5 or 10 no matter what you do, right? That's why this trick can work. If, on the other hand, that was 5x squared or this was y cubed, you'd have to do it the old-fashioned solving way. So I'm going to call this equation 1. I'm going to call this equation 2. And don't think of U and V as being variables. Just think of them as being numbers that don't matter too much. And what we're trying to do here is find out what X is equal to, right? Solve for X. So if that was 10 and this was 20, think of them like numbers like that. What I would do is, wouldn't you multiply this equation by -5? The top one.
Yeah.
Now, the reason why you want to do that by -5 is so that it becomes -5u, -5x, plus 25y. And then I'm going to leave the second equation totally alone. So far, so good? Now, what happens when I add these equations together is I get 5 minus v minus 5u, which is fine. They kill each other off, and we get 24y. Great?
Mhm.
Which means that it's not very pretty, but 1/24 v minus 5/24 u's, that's what y is equal to. And I've already half solved the question, right? I now know what y is in terms of u and v. Now, to get the x, don't you just pick one of them? Let's pick this one. No, let's not. Let's pick this one and replace that guy there. So v is going to be 5x, take away that guy. So, well, yeah, I wish I'd give myself more room. So v, take that guy away, but add it to both sides. Take that guy away is like adding, but then you subtract it from both sides. I hope I did this correctly. You get that fella. Does that look right? Take away, add. 2 takeaways is an add, then take away again. Okay. So I've got 25/24v, take away 5/24u equals 5x. So divide everybody by 5. I get 5/24v's, take away 1/24u's, and that's what x is equal to. Are we cool with that?
Yep.
Right. So to get this fella, I differentiate this guy here with respect to u, and I get -1/24. I then take this guy here with respect to v, and I get 5/24. I then take this guy here, which is the y, and do a u on him, which is what, -5/24. And I do this guy here, and I do a v on him, and I get 1/24. So that's going to get me -1/24 squared plus 25/24 squared, which gets me 24/24 squared, which gives me 1/24. Bingo.
A lot more work for the exact same answer.
Right, so if it is linear, and I have to keep emphasizing this, if it is linear, then that's the way to go. I think the good news is that virtually all of them are anyway, aren't they? That's kind of the go-to use subs that, you know,
Pretty much.
changing variables that they like. Okay. I wish I'd read the textbook more often, but I never do. Did the textbook show you the shortcut that I just showed you?
Hang on, let me check.
Because I know the textbook don't always do things the way I do it, and that can be a big distraction. Because I show you how to do something, then you go and watch the textbook, or you see a video and you find out, but that's not what he did. Even although the final destination is the same, right? And the route to get there may not be the same.
Integrals over rectangles, brackets, for digits, circle. Change a variable.
Okay, while he's doing that, let me finish with,
Shortcut.
do they have it?
No, they don't have the shortcut.
Hey, I'm still right. Okay, it works.
It works.
whether they do it or not. I wonder if I learned that way back in Scotland.
Huh.
I wonder if Scottish mathematicians know some tricks and they're not telling anybody. That would be cool, right? Right, let's do polar coordinates, double integral polar coordinates. Do you know if you take a function f of xy, right? You do a dA on it, and you can convert it into polar, right? And you get some other function, and you have an r dr d theta, right?
Mm-hmm.
And basically, if that's x plus y, don't you replace x by r cosine theta and y by r sine theta?
Yep.
Right. And you know, you can do cylindrical by just adding a dz at the end, so it doesn't really change much. Have you ever wondered where that weird r comes from?
You said it was the Jacobian, right?
Right, let's prove it. So we only have a few minutes left. In this format here, right? If you do dx by dr, dx by d theta, dy by dr, dy by d theta, right? You do the Jacobian. Let's see what you get. If you differentiate this guy with respect to r, you get cosine theta. If you differentiate this guy with respect to theta, you get negative r sine theta. If you do this with respect to r, you get sine theta. And if you do this with respect to theta, you get r cos theta. Right, what's the Jacobian? R cos squared theta. Take away a negative is adding it, r sine squared theta.
Pull it out.
R cos squared plus sine squared. R.
Yeah.